All right, welcome back. We are jumping into section 6.5. 6.5 is proving figures are special parallelograms. Grams. All right, the start thinking part says list the special parallelograms below and denote their defining characteristic. So we start here with a special quadrilateral, which is called a parallelogram. Parallelograms have both opposite sides being parallel. They have a bunch of other characteristics as well, but this is the characteristic that goes along with the definition of parallelogram. Now, the other special parallelograms that we have talked about are a rhombus, a rectangle, and a square. Now remember, the most important thing about a rhombus is that it is a parallelogram with all congruent sides. A rectangle is going to be a parallelogram with all right angles. Okay? And technically, even though we say all right angles, it really only needs one right angle because if one of them is right, we know that these angles are supplementary, so that one would be right, and we know opposite angles are congruent, so that one would be right. So technically, if you know it's already a parallelogram, it only needs to have one right angle, and all the rest will be right. But with rectangle, all right angles. Okay, a square is going to be all congruent sides and right angles. Okay, so that is what we learned in 6.4. Now what we're going to do is we're going to go the other way around. We're going to try to figure out how to prove a parallelogram is a rhombus. We've already done proofs proving that a quadrilateral is a parallelogram. Do you remember if the diagonals bisect one another, if the opposite angles are congruent, both opposite angles are congruent, if consecutive angles are supplementary, and then there was a bunch of other ways. Those are all ways to show that it is a parallelogram, that it's not just a four-sided figure, but it's a parallelogram. Now we're going to try to see how can we go further and show that a figure is a rhombus, a rectangle, or a square. So let's go ahead and move on. Basic justifications. If a parallelogram has right angles, then it is going to be a rectangle, which can be justified by definition of rectangle. If the parallelogram has two adjacent congruent sides, then it is going to be a rhombus by def of rhombus. Okay. The reason why it says you only need two adjacent congruent sides is because of something else we already knew about a parallelogram. If we have two adjacent sides that are congruent, by definition, not by definition of parallelogram, but a characteristic of parallelograms is that the opposite sides are congruent. So knowing that two adjacent ones kind of guarantees the other ones. So remember, mathematicians, crazy, lazy, and efficient, just going over and knowing that two adjacent ones is enough, then they don't want to continually show more than they have to. So showing two adjacent sides are congruent on a parallelogram, then it's definitely going to be a rhombus by definition of rhombus. Next one, if a parallelogram has a right angle and two adjacent congruent sides, then it is a square. Okay, and that would be by definition of square. Now we're going to look at some other theorems. These are just the basics. This is like going over and showing that it is those figures just by its definition. That's like proving that something is a parallelogram by going over and showing both pairs of opposite sides are parallel. We had that, but then we had a bunch of other ways to show that a figure is a parallelogram. Let's look at some other ways. So when we look at this, it says a parallelogram has diagonals that are perpendicular, or if a parallelogram has diagonals that are perpendicular, then that figure is going to be a rhombus. Okay, so that is another way to show it's a rhombus. You can show that the sides are congruent, and that'd be definition of rhombus, or you could go over and if you had a parallelogram, remember you have to already know that it's a parallelogram, but if you already know it's a parallelogram and you see that the diagonals are perpendicular, then that thing is going to be a rhombus. That is one of our theorems we are going to be able to use. The next one says, if a parallelogram has diagonals that bisect both angles, then the figure is a what? That one is also going to be a rhombus. And you can kind of think of this like kind of the converse of, do you remember if we knew it was a rhombus, then the diagonals bisect the angles? Well, we're kind of doing the converse. So once again, if you had a parallelogram, you already knew it was a parallelogram, and then you knew that those were congruent and that these were congruent, then that thing would be a rhombus. Okay. So now let's look at what else we have. The next one says if a parallelogram has diagonals that are congruent, then it's going to be a what? Do you remember what was the one that had diagonals being congruent? Rectangle. So if you have a parallelogram and you already know that that is congruent to that, then it is going to be a rectangle. Okay, that's a way to show that it's a rectangle. Now let's keep on moving on. Is that it? Yes, that's it. Okay, now it's important for you guys to understand that if you wanted to prove something is a rectangle, then you can either do definition of rectangle or you can do the diagonals being congruent. If you want to show that it's a rhombus, let me go ahead and write this out actually. So if you wanted to show that it was a rectangle, wanted to show as a rectangle, one way to do it is show that it's a parallelogram and it has that right angle. Or you could go over and show it's a parallelogram and show that the diagonals are congruent. Those are our two ways to show something is a rectangle. Then if you want to show that it is a rhombus, one way is it's a parallelogram and it has two adjacent sides that are congruent. The other way was if you went over and showed the diagonals were perpendicular. And then the last way was if you could show that a diagonal bisects that angle and bisects this angle as well. So you might be saying, well, how do I show that it's a square? You can either go over and do definition of square, or you can have one of these. If you show that it has one of these, meaning it has a right angle or the diagonals are congruent, and then you also had one of these, showing either the two adjacent sides are congruent, the diagonals are perpendicular, or the diagonal bisects the angles. If you had one of each one of those, then you would know it was a square. So one of each. It's kind of like pick whichever one you want. If you had it has right angles and you also had that it was that the diagonals were congruent, that is just two things saying it's a rectangle. So that doesn't push it into the land of being a square. It needs to have one from rectangle and one for rhombus. So when we look at this thing right here, what is the most specific name for the parallelogram? Luckily, they already told us it's a parallelogram, so we can skip going through those ways of showing that it's a parallelogram by like diagonals being bisecting one another, opposite sides being congruent, and so on. We can skip all that because they've already told us it's a parallelogram. So now let's take a look at this. What did they give us here? We know it's a parallelogram and it has a right angle. So what type of figure is it? That comes from the land of rectangle. So the figure must be a rectangle. We already knew it was a parallelogram and it has the characteristic which pushes it to being a rectangle. The reason is the right angle. Now remember what I said, you only need one right angle if you already know it's a parallelogram because you know opposite angles are going to be congruent and you know that the consecutive angles are going to be supplementary. So that knowing you have one right angle in a parallelogram guarantees all of them are going to be right. Now let's look at this one. We knew it's a parallelogram Do we have enough to push it now into the land of rectangle or rhombus or both and call it a square? Well, since we have the diagonals being perpendicular, that comes from the rhombus proof. So that would be a rhombus because diagonals are perpendicular. Ta-da! Let's keep on going. So the next one, we know it's a parallelogram, and now they tell us that the opposite angles are congruent. So what is that? What's that push it to be? It doesn't push it to anything, remember? This right here is just one of the things that we knew about a parallelogram. So we already knew it was a parallelogram. They gave us another characteristic which tells us it's a parallelogram. So that didn't push us any more specific to call it a rectangle, a rhombus, or a square. So this is just going to be a parallelogram. Reason, both opposite angles congruent, or just the given. Remember, it was already given that it was a parallelogram. Okay, now I want you guys to try this one. What is this figure going to be here? We already know it's a parallelogram. Do we have enough to push it to being a rectangle, rhombus, or square? Well, remember we have two sides here, and these sides are going to be adjacent sides. Knowing that it's a parallelogram makes us know that the opposite sides are also congruent, so this would be a rhombus. And the reason being, two adjacent congruent sides. Okay, now what about if they did this? If instead of them being adjacent sides, if they just said these sides? Well, this is a parallelogram already, we would know. And then they say one pair of opposite sides are congruent. That doesn't push us past knowing it's a parallelogram. So that would not be enough. They have to be adjacent sides. Okay. All right, let's go ahead and do the next one. I want you guys to try this one now. We already knew it was a parallelogram. Does this information push it into being a rectangle or being a rhombus? The extra information they gave you. Well, let's look at this. We have the adjacent sides that are congruent. What does that make it? A rhombus. Then it says that the diagonals are congruent, so that would be a rectangle. And those two things together make it a square. Square because of two adjacent congruent sides and also diagonals congruent. Okay, let's look at this one right here. How can we prove, what is this going to be? Well, it has a diagonal, and the diagonal seems to be bisecting angles. We already know it's a parallelogram. Does that push it to being something else? Yep, that pushes it to being a rhombus. So this is going to be pushing it to being a rhombus. And the reason being would be diagonal, bisects both angles. Now, if you wanted to do a proof on this, remember, we don't do way too many proofs anymore, but we do use the logic from a proof. Let's try to think through the logic. Is triangle 1 going to be congruent to triangle 2? Well, we know that this is congruent to that, this is congruent to that, and then you have the reflexive property. So by SAS, we know the two triangles are congruent. Triangle is congruent to triangle. We then know that the corresponding parts are congruent. So we know that one's going to be congruent to that one, and this one is going to be congruent to that one. Looking at that, that doesn't make any sense. We didn't make a rhombus. We made a rectangle. Now there's another piece here. Not only do we know those are congruent, and these ones are congruent, but across from these congruent angles must be congruent sides by the converse of the base angles theorem. So what that says is if this is one tick, then this one also is one tick. We don't have to use two ticks. If that one's one tick, then across from the other 30-degree angle is going to be one tick, and that would be our reasoning. The two triangles are congruent by SAS, therefore the sides are congruent, and then using that paired with the converse of the base angles theorem, we know all the sides are congruent, hence a rhombus. Let's keep on cranking. Almost done. Okay, explain why the following parallelogram must be a rectangle. Huh? Why would this be a rectangle? I see the stuff having to do with a rhombus. It's definitely going to be a rhombus because the angles are both bisected. So the diagonal bisects the two angles. That makes it a rhombus. Maybe I wrote this down wrong. Nope, I did not. Okay, it is a rhombus because of the diagonal bisecting the angles. Okay, now what does 45 and 45 together make? 90. So that makes it a rectangle. And that is because of the right angle. The funny thing here is I'm pretty sure that I meant when I was writing these notes to say, why does this have to be a square? The reason why it has to be a square is because it has a characteristic from rhombus and it also has a characteristic from rectangle. So that would be a square. Okay. Now, looking at this, which of the following would be enough added information to determine that the parallelogram is a square? Which parts here? Name all that apply. You already have the information that it's a parallelogram and you have this. What else would you need? A or B or C or D or E or F? Which one of these would be the extra piece of information that you would need to know so that you could guarantee this thing is a square? Well, let's see. Diagonals are congruent. That makes it a rectangle. Diagonals are perpendicular. That is a rhombus. Diagonals bisect the angles. That's a rhombus. One angle is right. That makes it a rectangle. Diagonals bisect one another. That's just a parallelogram. Opposite angles are congruent. That is a parallelogram. This right here has already checked off your box for rhombus. So we've already done rhombus. If we go over and circle like B, that would just be two pieces of information saying it's a double rhombus. Well, that doesn't push it to being a square. Since we've already taken care of rhombus, we need something from what land? Rectangle land. So which one of these was rectangle? It could have been the given information and then A, or the given information and D. Either one of those, A or D, would have been enough information to add to the given to show that this thing is a square, because we already knew by this that it's a rhombus, so we just need to know which one of these pieces of information makes it a rectangle, which pushes it all the way to the most specific, which is a square. Okay, explain why the following figure cannot be a rhombus. Why can this definitely not be a rhombus? Well, what's the given information? That this is 30 degrees and this is 60 degrees. Is it possible for the sides across, or the side across from a 60 on a triangle to be the same length as across from a 30? Nope. Remember, across from the bigger angle is the bigger side. Across from the smaller angle is the smaller side, which means that this side has to be bigger than this one. This one has to be smaller. And in order for this thing to be a rhombus, we would have to know that all the sides were congruent. So therefore, this is definitely not going to be a rhombus. Now, one wonky thing you might end up seeing in a standardized test, I don't like giving these problems because they take a long time, but basically you could go over and prove in a coordinate plane that these things are that this thing is a rhombus, and we're actually going to get into this in a future section. So don't worry about this right here. We're going to be dealing with like figures in coordinate planes in a future section, and I also don't give you way too many of them because they actually take a long time. But if you were curious, if you're like, I can see that we've been looking at these not in the coordinate plane, but what about in the coordinate plane? Well, that's coming in a lesson that we're about to do. All right, now the last thing I wanted to show you was the path to proof wrap up. I want to remind you of, here we go, to show that something is a parallelogram. To prove that something is a parallelogram, I'm going to write out all the ways. Both opposite sides are parallel. Both opposite sides are congruent. Both opposite angles are congruent. Consecutive angles, A, B, and B and C, both add to be 180. Both consecutive angles are supplementary. We also talked about how one pair of opposite sides could be parallel and congruent. I believe no, we had one more. Diagonals bisect one another. So those are the ways, if you wanted to push from something just having four sides, being a quadrilateral, to being a parallelogram, that's the way. To push it to being a rectangle, one way is that you have a right angle, or that the diagonals are congruent. So that's how you show that it's a rectangle. To show that it's a rhombus, you can show that two adjacent sides are, if you already knew is a parallelogram, then two adjacent sides are congruent. You could also show that the diagonals are perpendicular, or you can show that a diagonal bisects the angles. That's how you show it's a rhombus. And if you want to do a square, it'd be one of each. There you go. That is how you prove figures are rectangles, rhombi, and square. Now you're always hoping that they've already taken care of this part and they tell you it's a parallelogram, because then you can skip having to show one of these things. All right, hopefully that made sense. Come to class with questions if you have any.